Hello students, welcome to chemistry class. Today we are going to discuss about chemical kinetics. The subtopic is integrated rate law for the first order reaction. Integrated rate law for first order reaction. So what is mean by first order reaction? A reaction whose rate depends on the reactant of concentration raised to the first power is called a first order reaction. For example, A is one of the reactant, power 1. So this reaction is example for first order reaction. Once again repeating. Now a reaction whose rate depends on the reactant concentration raised to the first power is called a first order reaction. Okay, we consider A reactant gives product. How to write rate law? We already know that rate is equal to the product of rate constant and initial concentration of the reactant. Okay, once again, rate is equal to K into initial concentration of A. Now we determine differentiate of concentration of minus d of A by divided by dt. How? So we already know that rate is equal to the change in the concentration of reactant by time taken. So minus d of A divided by dt is equal to K into initial concentration of A. Next, the concentration of A will come same side, minus d of A divided by A, and dt next stage. So K into dt. Now the initial time is 0 at the time concentration of A naught to A. Okay, we take integrated minus integral A naught to A minus d of A divided by dA equal to K is a constant 0 to t dt. We already know that in integrated formula integral dx is equal to x plus c. Now minus here minus d of A divided by A means ln A naught to A equal to K is a constant, here t plus c is a integral constant, so t of 0 to t. Now minus ln A minus ln A naught equal to K into t minus 0. Next, minus ln A, minus into minus of plus ln A naught is equal to kt. Okay, next ln is a common one, so ln is equal to ln into A naught by A, because plus value, so numerator, negative value A is a denominator, so K into dt. Now we converted ln is converted into as usual logarithm. We want addition of some constant, here 2.303 into log of A naught divided by A, that is initial concentration, the concentration at the time t, so K into t. Okay, here ln is converted into as usual logarithm, so 2.303 log of A naught divided by A is equal to kt. Okay students, next here K value, K is a rate constant. Okay, K is equal to 2.303 by T log of A naught divided by A, initial concentration by final concentration. We are plotted against graph ln A and time taken. We know that initial concentration is increases, and depending upon the time, concentration will decreases from the graph. Okay, equation number 2 means we apply the y is equal to mx plus c. Here ln a naught minus a is equal to kt. Here ln a is a concentration at the time t equal to ln a naught minus kt. This equation is plotted against y is equal to mx plus c. We get a negative slope. We plotted against ln a and time taken. We get the straight line and is negative slope is evidence for the first order rate equation. Okay, this equation is very important for 5 mark question. Okay, full derivation is important one for 5 mark question. Derive the first order rate constant for the reaction. Okay, next question. Example for first order reaction. 3 mark question, very important. 3 marks. What are the example for first order reaction? Okay, the first one, decomposition of dinitrogen pentoxide. Formula for dinitrogen pentoxide, N2O5 in gaseous state. We get 2 moles of nitrogen dioxide and half moles of oxygen. This reaction follows first order kinetics. Next one, decomposition of thionyl chloride. Formula for thionyl chloride, SO2 and Cl2. In liquid state, it undergoes decomposition reaction to form sulfur dioxide and chlorine. This reaction also follows first order kinetics. Third one, decomposition of hydrogen peroxide in aqueous solution. Hydrogen peroxide undergoes decomposition reaction to form water and half moles of oxygen. This reaction also follows first order kinetics. Next one, isomerization of cyclopropane to propane. Cyclopropane is nothing but CH2 bond, CH2 bond, CH2 bond. This compound undergoes isomerization reaction at 783 Kelvin to form propene. Okay, propene ENE because double bond compound propene. This reaction also follows first order kinetics. And one more thing, the hydrolysis of methyl acetate, formula CH3COO CH3 plus water in presence of acid medium. It gives methyl acetate undergoes hydrolysis reaction in presence of acid medium to form acetic acid and methanol. This reaction is one of the esterification reaction. This reaction is example for first order kinetics. Okay students, thank you.